Space, once the exclusive domain of nations, is rapidly becoming commercialized. The number of satellites in orbit has skyrocketed in recent years. Just a decade ago, around 1,000 operational satellites circled our planet. Today, that number has more than doubled. And, well, the trend shows no signs of slowing down. Projections suggest that tens of thousands or even hundreds of thousands of satellites could be launched in the coming decade. This unprecedented growth in space activity promises to revolutionize communications, Earth observation, and scientific research. But it also raises serious concerns about the sustainability of our activities in space. This new space age is driven by the plummeting cost of launching payloads into orbit. Reusable rockets and the miniaturization of satellites have made space more accessible than ever before. Companies like SpaceX, with its Starlink constellation, are launching thousands of small satellites to provide global internet coverage. Other companies are following suit, eager to capitalize on the burgeoning space economy. This rapid increase in the number of satellites has led to growing concerns about the potential for collisions and the long-term sustainability of space operations. As more and more satellites are launched into orbit, the risk of collisions increases dramatically. Space is vast, but the region of low Earth orbit, where most satellites reside, is becoming increasingly crowded. The sheer number of objects in this region, from operational satellites to defunct spacecraft and fragments of debris, raises the probability of a catastrophic collision. Even a small piece of debris traveling at thousands of miles per hour can cause significant damage to a satellite. Experts warn that we are approaching a tipping point, where the density of objects in low Earth orbit could trigger a cascade of collisions, known as the Kessler syndrome. This scenario, once the stuff of science fiction, is now a real concern. A single collision could create thousands of pieces of debris, each capable of causing further collisions. This chain reaction could render entire orbital altitudes unusable for generations. The increasing number of satellites in orbit has led to a surge in conjunction events, or close approaches between objects in space. These events require careful monitoring and often necessitate collision avoidance maneuvers. Satellite operators must constantly track the positions of other objects in space and make adjustments to their satellites' orbits to avoid potential collisions. These maneuvers consume valuable fuel and can shorten a satellite's operational lifespan. The frequency of conjunction events is staggering. In 2022 alone, over 4 million conjunction events were predicted, a 134% increase from just 2 years prior. As the number of satellites continues to grow, the number of conjunction events is expected to increase exponentially. This will place an even greater burden on satellite operators and increase the risk of collisions. The current system of collision avoidance, which relies heavily on manual intervention, is not sustainable in the long term. Adding to the congestion problem is the growing amount of space debris in orbit. This debris consists of everything from spent rocket stages and defunct satellites to fragments of previous collisions and even flecks of paint. The European Space Agency estimates that there are over 36,500 pieces of debris larger than 4 inches in diameter, about 1 million objects between 0.4 and 4 inches, and a staggering 130 million fragments smaller than 0.4 inches. Even these tiny particles can cause significant damage due to their high speeds. This debris poses a significant threat to operational satellites. Collisions with debris can damage solar panels, disable sensors, or even destroy a satellite entirely. The International Space Station, for example, has had to perform numerous debris avoidance maneuvers over the years to avoid potential collisions. The problem of space debris is self-perpetuating. Collisions between objects in orbit create more debris, leading to a vicious cycle that could eventually make space exploration and utilization impossible. Section 5. Altitude Matters, A Tale of Two Orbits. The risk posed by space debris varies depending on the orbital altitude. In low Earth orbit below about 600 kilometers, atmospheric drag plays a significant role in removing debris over time. Satellites and debris at these altitudes experience a slight drag from the residual atmosphere, which gradually slows them down and causes them to re-enter the Earth's atmosphere, where they burn up. This natural cleaning mechanism helps to mitigate the debris problem at lower altitudes, though it is not a complete solution. At higher altitudes, however, the atmosphere is much thinner, and atmospheric drag is negligible. Objects at these altitudes can remain in orbit for decades, centuries, or even millennia. This means that debris generated at higher altitudes such as in geostationary orbit poses a much longer-term threat. The accumulation of debris at these altitudes is a serious concern, as it could eventually lead to a scenario where certain orbital regions become unusable. Section 6. The Quest for Solutions. Addressing the challenges of space congestion and debris requires a multifaceted approach. There is no single solution to this complex problem. Instead, a combination of regulations, international cooperation, and technological innovation will be necessary to ensure the long-term sustainability of space activities. Without concerted action, we risk jeopardizing our access to space and the many benefits it provides. One crucial step is the implementation of stricter regulations governing the design, operation, and disposal of satellites. These regulations could include requirements for spacecraft to be designed for easier deorbiting at the end of their operational life, as well as limitations on the amount of debris that can be released during launch and operations. Such regulations would help to mitigate the creation of new debris and encourage responsible behavior in space. Section 7. The need for international cooperation. Space is a global commons, and addressing the challenges of congestion and debris requires international cooperation. No single nation can solve this problem alone. Countries must work together to develop common standards and guidelines for space activities, share information about satellite orbits and debris tracking, and coordinate efforts to mitigate the risks. This will require overcoming geopolitical differences and prioritizing the long-term health of the space environment. International cooperation is also essential for developing and implementing debris removal technologies. These technologies, which are still in their early stages, could one day be used to remove existing debris from orbit, preventing further collisions and protecting operational satellites. Developing and deploying these technologies will require significant investment and collaboration among nations. The benefits, however, could be enormous, ensuring the long-term sustainability of space activities for all. Section 8. Technological Solutions, Cleaning Up Our Act. While regulations and international cooperation are essential for preventing the further accumulation of space debris, technological solutions are needed to address the debris that is already in orbit. Several promising technologies are being developed, ranging from simple nets and harpoons to more sophisticated concepts like laser brooms and robotic servicing missions. Each technology has its own advantages and disadvantages, and it is likely that a combination of approaches will be needed to tackle the diverse range of debris objects. One promising concept is the use of space-based lasers to deorbit small debris objects. By targeting these objects with a powerful laser, it is possible to alter their trajectory slightly, causing them to re-enter the Earth's atmosphere and burn up. This approach could be particularly effective for removing small debris objects, which are difficult to capture with other methods. Another promising avenue of research is the development of robotic servicing missions that could rendezvous with and deorbit larger debris objects or even repair and refuel aging satellites, extending their operational lifespan and reducing the need for new launches. Section 9. The U.S. takes action. Recognizing the growing threat of space debris, the U.S. government has taken steps to address the issue. In July 2024, the White House released the National Orbital Debris Implementation Plan, a comprehensive strategy outlining the government's plans to mitigate the risks posed by orbital debris. The plan includes measures to improve debris tracking and characterization, develop and demonstrate debris removal technologies, and promote responsible behavior in space through international engagement and the establishment of new regulations. The plan also calls for increased investment in research and development of space situational awareness capabilities, which are essential for tracking and characterizing debris objects. This includes the development of new sensors and data processing techniques to improve the accuracy and timeliness of debris tracking information. The plan also emphasizes the importance of international cooperation in addressing the debris problem and calls for increased collaboration with other nations to develop common standards and guidelines for space activities.